Good evening, Cecilia.
Good evening.
How are you?
I'm good. How are you?
I'm good. So your text message said you got called for um,
Um, a rehearsal? Well, it's because sometimes they change our rehearsal schedule for choir and stuff.
oh, so it's a choir. That's what I was curious about, was what you were rehearsing.
Yeah. So sometimes even though they send out the schedule, sometimes they change it and we're supposed to just change along with it.
Uh-huh. Okay. Yeah, there's no problem at all when you do that with me. Especially as long as I'm open as wide as I was tonight. So,
Yeah.
okay. Let's see. If we pick up with where we left off, we did 13 last time. So let's look at 14.
Um,
If you can't, let's see. C is the set consisting of all of the fractions whose numerators are in set A and whose denominators are in set B. And then it's what is the product of all the numbers that are in C. So if we have A equals 1, 2, 3, and we have B equals 2, 3, 4. So C would be what?
um, C would be 2 over 1.
The whose numerators are in A.
Oh,
And
sorry. 1 over 2.
that's okay. That's the first thing. What's another term that's
1
in C?
over 1 over 3. And 1 over 4. 2 over 2. 2 over 3. 2 over 4. 3 over 2. 3 over 3. And 4 over 3.
Okay, we're going to multiply all these together, so I don't need to do the ones.
Why not? Because you're just taking them out. You don't have to add them later.
I'm multiplying. They want the product of all the numbers that are in C.
But,
So it's,
oh,
in other words,
oh.
1/2 times 1/3 times 1/4 times 1 times 2/3 times 2/4 times 3/2 times 1 times 3/4. So that number is what we want. It looks like we have a 2, a 2, a 3, and a 3. So we have 36 in the numerator. What do we have in the denominator? A 2,
Then you have to...
2, 3, 4 is 12. And we have a 2, 3, 4 over here, which is another 12. So we have a 12 times a 12 times a 4. Oh, no, we don't have a 2, 3, 4. We had a 3. Yes, we had a 2, a 3, and a 4, and another 4. So I think that's right. You see,
1 second.
you see the way I've done that? I multiplied this 2 times 3 times 4. I don't know how I came up with 12. I should have come up with 24. Here, let me change that.
Yeah, I was like, there's something...
Big time wrong with that. Okay, so that 2 times 3 times 4 is 24 times that 2 times 3 times 4, and then times the last 4. So now I can do this.
So when you calculate the 36...
I just multiplied all the numerators. I multiplied 2 times
Oh,
2
12 times
times
3, never mind.
3 times 3,
Yeah, okay.
which is 6
And
times 6.
24 times 24 times 4, and then that goes in there, and that's 9. So you
So
have
now we have
9 over...
9 over I can say 4 is 3 times 8, and I can say this 24 is 3 times 8, and now I can get rid of that, that, and that. So I have 1 over 64.
Then you would have to know that, that that's what you're supposed to do.
Well, not really. I was just going to point out that that's kind of a nifty little trick, because 9 over 24 times 24, that's harder math to do, because there's no common. Oh, I'm sorry. It's not that hard to do. I can divide 3 into the top and 3 into the bottom, and then 3 into the top and 3 into the bottom again, so I can come up with 1 over 64 easy enough. Yeah, the difficulty isn't the arithmetic. The difficulty is coming up with these 10 fractions that make up set C. Okay. Let's see, there's one more in decimals and fractions. For the final step in a calculation, Ezra accidentally divided by 1,000 instead of multiplying by 1,000. What should he do to his correct answer to correct it?
Oh, it's incorrect, right?
I'm sorry, what should he do to his incorrect answer to correct it? Yeah.
Multiply by 1,000? No, you should multiply by a million, right? Because you
Yes.
got 3 the wrong way, and then you need another 3.
Right. The way you could figure it out is, let's say he had 2,000 and going into his final step, and he divided by 1,000, coming up with 2, when he should have multiplied by 1,000. So he should have come up with 2 million.
Mm-hmm.
So to get from 2 to 2 million, you got to multiply by a million. Okay. Let's go to percents. And again, I can't believe they actually have a section on percents.
That's fine. Let's go over it. You might as well.
Well, it turns out I've looked at this before, and it's not just about converting decimals to percents and vice versa. We know how to do that. But so 25 students took an exam, and 4 of them failed. What percent of them passed?
Well, if 4 of them failed, you have 21 left.
Okay. So to come up with the percent, we're going to divide that. First, we want to come up with a fraction.
Yeah, oh, I just did it. Sorry. It's 21 over 25 times 100, which is equal to 84.
Okay.
I mean, 21 and 25 is not exactly great numbers to have to divide.
Well, let's look at an easier way to do this. If I can figure out what percentage of them failed, I'll also get my answer.
Oh, you did 4 over 25.
Now, notice how I can convert this to percent easily. I can multiply top and bottom by 4, and I get 16 over 100, which I know is 16%. Subtracting from 100 gives me 84%, must be my answer. So the arithmetic is slightly easier if you work with 4 over 25 as opposed to 21. Although not really. If I have 21 over 25, I can still multiply top and bottom by 4 and immediately get to 84%. The key is to try to get 100 in the denominator of a fraction, and then you can convert it to percent easier. Excuse me. So she bought a $60 sweater on sale at 5% off. How much did she pay, including a 5% sales tax?
1 second. Sorry, I'm calculating. I want
Oh,
to
that's
know.
okay.
I know how to do this. So,
Okay.
63 point. That's not right then. Well, I took
It's
the
two
5%
steps.
off the sweater
Let's,
first.
yeah, let's do it in 2 steps. What was the price of the sweater?
Oh, now I know what I'm doing wrong.
Okay.
Well, the price of the sweater is 57, and then you just
Okay.
add the 5% sales tax to the 57.
Plus 5% of 57, right?
So it's
Not 5% of 60, but 5% of 57, because you only pay the sales tax on the 57.
yeah,
So
that's what I did.
an easy way to do that is, at least the way I would do it, is I know what 10% of 57 is. It's $5.70. $5.70. So 5% is half that number, which is a little harder to come up with, but not really. $285. So there's my sales tax.
Yeah, the answer is D.
Yeah, so
I
I
did
add,
it right. I did it right. I just wrote 67 instead of 57, which kind of makes it a difference.
okay. You can almost estimate this. We know it's not 60. There's no way it can be 60, because once you take 5% off and do 5% of a smaller number, it's not going to get back up to 60. And yet it's going to be very close, and that's the only thing less than 60 and close to 60. But we can do the math. Is not hard to do on that one, so we don't need to be approximating it. What is 10% of 20% of 30%?
So you have to take 10% of 20 first, right?
Yeah, or of means multiply. So the other way I could do this problem is 0.1, that's 10%, times 0.2, that's 20%, times 0.3. What is that? 0.006? Well, all of my answers are in percent. So I've got to convert that decimal back to percent. What is that?
It's 6.
0.6. In other words, I want to move my decimal point 2 spots to convert to percent. So this is equal to 0.6%.
Yeah.
Okay? And that's one of many ways you could do it. I converted them all to decimal, multiplied them, and then converted back to percent. You could do 10% of 20%, which is 2%. So now I have 2% of 30%. Well, 10% of 30% would be 3%. So 0.6%, I can get there by working entirely in percents. But the problem is actually more confusing because they say percent, percent, percent. And that's why I converted everything to decimal, because I know OF means multiply. So, okay.
Yeah.
Number 4.
If C is a positive number, 500% of C is what percent of 5C?
Oh,
I don't know.
500.
Can't you just take one like positive number, picking a number?
Yeah. Picking numbers should work. So what number are you going to let C be?
I don't know, 100?
Okay. So what is 500% of C? right?
500.
Okay. And 500 is what percent of 500 times 100?
So that's 50,000. 500.
Is what percent of 50,000? So 500 equals, let's figure out, first of all, let's not have a percent in a equation. We're not used to seeing the percent sign in an equation. So what decimal is x? And then we'll make it that percent. So 500 is what of 50,000? What fraction?
What fraction?
What is x equal to?
One.
Well, x would be 500 divided by 50,000.
Yeah, well, it must be 1.
So it's 1/100th equals x. So x is equal to 1%. I mean, the answer, since they are asking what percent it is, it's 1.
Yeah, well, that's what I got.
Okay.
1.
What percent of 50 is b?
A. But you're missing times 100.
Pick a number for b. What percent of 50 is, let's say b is 25. So what percent of 50 is 25?
Half.
It's 50%. So that's our answer. Now let's go through all these answers and see, when we plug in 25 for b, which one is equal to 50?
C.
No, because we got to plug in 25.
The other way around. The other way around.
A.
A. So I was right.
Yeah. So b over 50 is, what percent of 50 is b?
Well, it equals to a half. So that's
Right.
equal to 50%.
Right. Right. Okay. Number 6. Yeah, let's do that one. This is in the making of all the ones we've done so far. 8 is 1/3% of what number? Translate that to an equation for me using decimal.
Well, 0.33%.
Which is what in decimal? So it's point.
0.333333.
Well, so they're saying 33% of x equals 8. So 8 is 1/3% of what number? There's my equation, but like I said, we're not used to percent signs in equations, so let's change it to decimal. So what decimal is that?
I mean, you would have to divide it or multiply it by 100, right?
Divide it by 100.
Divide it by 100.
Right. And the way, in other words, we're going to move this 2 spots this direction. So we're going to add 2 zeros. That decimal represents 1/3 of 1%. And notice that 1% is this decimal. So this has to be a smaller decimal than 0.01. So I know I'm right here, 0.003. In other words, when I do my ballpark check to make sure I have the order of magnitude right, this feels right. This compared to 1%. Okay? So now I have 0.00333 times x equals 8. So x is 8 divided by 0.033. And what is that? That is 24.
That's 2.4, right?
Yeah, and the way I do that would be I would do 8 over 1/3, which is 24, only it's 1/3%, so it must be 2,400. Okay, during his second week, Mario earned 110. That represented 25% increase over what he earned in the previous week. How much did he earn during the first week?
So $110 is equal to 125%.
Yes.
Because he started with 100, and so
So we could back solve it, right? If 110 equals 1.25 times x, x being what we started with, then that'll be the answer. So you could do this.
110 divided by 1.25?
Yeah, but that's kind of hard to do manually. Don't you think?
A little.
Okay, so there might be an easier way to do this. Let's back solve it. We know the answer is not D or E. It's got to be less than 110. So let's start with 85, and if that's not it, we'll know the answer. So let's take 125, 1.25 times 85. Well, 1 times 85 is 85. 0.25 times 85 is a fourth, which is another 21 and a fourth. Add those two together, we don't get 110. We get 106. So what does that tell us? What's the answer got to be?
88.
Right. So an 88 is going to be 88 plus a fourth of 88. That's 110. To me, back solving makes the math a lot easier rather than trying to divide 110 by 1.25. Okay, number 8.
At Bernie's bargain basement, everything is sold for 20% less than the price marked. If Bernie buys radios for $80, what price should he mark them if he wants to make a 20% profit on his cost?
Algebraic, back solve.
Well, 20% of 80 is 16.
Okay. So he wants to make $16 profit.
But he also wants to sell it for 20% less than the marked price. So you both want to sell it 20% less than the marked price and make a $16 profit, right?
Right.
So he needs the price to be more than $96.
Okay? Because it's going to get marked off, right? If he priced it at 100, it would be sold for $80, and he wouldn't make any profit at all.
Exactly.
Okay.
I was just like, I'm eliminating A, B.
No, I know. To me, this is actually a classic back-solving problem. Because the algebra is so hard. The algebra is pretty complicated. But if we start with their answer, we can make it real easy, right?
Mm-hmm.
B clearly doesn't work. Could B, they're going to sell it to the customer for $80. Bernie's not going to make any profit at all.
Mm-mm.
Okay, so we know we need to go up. What's the next one we should try?
D.
D.
I want to say it should be 120.
Okay, let's see if 120 works. He's going to...
If it's 120 and he marks it down, that's 20% of 120 is 24, which makes it $96, which is what he needs to get half.
Exactly. So D is correct. Notice how much easier it was to do it by back solving.
Mm-hmm.
It's real easy to rule out 100, so in other words, working through the math is a piece of cake when you do the back solving. Coming up with the algebraic expression to solve this is much harder. And not only that, but it's classic because if you guess wrong with your first price, you're going to know whether to go higher or lower. And that's the key that makes back solving almost for sure the correct way to do it, when you're going to know whether you have to go up or down. My gosh, I'm sure I can read this. I can read it. I'm not sure you're going to be able to read it. I can blow it up a little bit if it would help, or can you make that out?
Mm-hmm. Okay, Mrs. Fisher usually deposits the same amount of money each month into a vacation fund. This year she decided not to make any contributions during November and December to make the same annual contribution that she had originally planned. By what percent should she increase her monthly deposits from January through October? Well, I mean, so 12 months is equal to 100%, right?
Yeah, but notice they didn't tell us any numbers here. In other words, if you're looking for a clue as to when you should use pick numbers, this is a good case. Because they didn't tell us that she deposited $10 per month into the vacation fund, some amount. Whenever they don't tell you the amount, then we can make it up. And it'll be so much easier if we're working with some concrete numbers to figure out this answer.
Mm-hmm.
So give me a number that she might deposit every month into this vacation fund.
$100.
Okay, so over the course of the year, she would want to deposit $1,200 if she was going to do $100 a month.
Mm-hmm.
Well, she decides not to do any in November and December, but she still wants to deposit $1,200, but she's only going to have 10 months to do it. So how much does she have to deposit each month, January through October?
120?
Now, by what percent did she increase it?
It's the difference. What is the formula?
It's the difference in the two prices, always divided by the original.
The original. So
Always
it's
the original.
20.
That's the key.
So
So,
it's 20 divided by 100 times 100.
no, that's just 20%. Yeah. Yeah, you're right. It's 20 divided by 100 times 100.
Times
Yeah.
100. Yeah,
Uh-huh.
but I'm just thinking, I mean, I know how to do that in my head, but I'm just thinking
Mhm.
if I got this problem with numbers that weren't, as easy.
Well, we made them up. So we had the ability to make them as easy as we wanted. But notice I could have used anything. I could have used $8 a month. $8 a month would have meant she wanted to deposit $96. So in order for the year, and if she's going to do 96 only in 10 months, she's going to have to deposit $9.60 per each of those months, which is an increase of 20% over $8. So it didn't matter the numbers we picked. They didn't even have to be all that nice. But the key is knowing to use the pick numbers. Because when you pick numbers, this problem becomes very simple. It would just be very tough to figure out algebraically how to solve it. And picking numbers always goes with back solving. In other words, you don't just pick numbers, well, I shouldn't say that, I guess. We picked numbers and we're actually able to figure out the answer without multiple choice. In other words, this could have been a fill in the blank and we would have been able to do it even though we picked numbers. So that was actually incorrect. It doesn't always go with back solving. But usually it does. Usually when you're picking numbers, you're then testing each of the 5 solutions. But actually that wasn't the case there. So, all right, let's see. A price of a loaf of bread. Now, at some point, Cecilia, we probably want to start spending more time on the tests, maybe half and half. What do you think about that? We were doing 3/4 of an hour on this part and 15 minutes on the tests, but that doesn't really probably give us enough practice on data sufficiencies.
Well, that's fine. We can switch over.
About half of those problems are data sufficiencies, so if we switch to the test and do a half hour of the test, you're going to get about 15 minutes of data sufficiencies, which is just about right. That's 1/4 of the hour. So let me bring up that test. Let's see, it was test number, we were on number 11 of test 5. Amazing what a difference a white background makes. Actually, it's more than just a white background. It's a white background and clearer letters. Okay, number 12.
Oh, man. That does not look fun.
Oh, these are easy. You just got to know what to do. The principle, let me give you the principle. Here's the principle.
Yeah, I know that part.
Or multiply numerators, multiply denominators.
Well, square root 2 times square root 2 is 2.
Okay, so we're going to so we got square root of 10 times square root of 5 all over 2 after we multiply numerators and multiply denominators.
Mm-hmm.
Now what's the new numerator? What's square root of 10 times square root of 5 equal?
Well, I want to say square root of 25.
Square root of 50. In other words, this is also true. Square root of a times square root of b is equal to the square root of a times b. So both of these are true. In other words, you can combine what's inside the radical to make square root of 50 divided by 2. And then square root of 50 is what? How can I simplify that? I guess we haven't done a lot of these. Let's talk about let's leave this for a moment on how to reduce this. And tell me how to reduce this. How to simplify that. Square root of 200. How would I?
No.
You want to factor it. You want to factor it into something that's a perfect square. So the square root of 200, 100 is a perfect square.
Mm-hmm.
And then it becomes 10 root 2. So always break whatever number you're up into two factors where one of them is a perfect square. Okay? So square root of 50 would be what?
Oh, it would be 25, square root 25 times square root 2.
Okay, so that's 5 root 2.
2 over 2.
That should be an answer on there. Okay, there it is. Yeah. Okay. We could have also just taken that and made that square root of 5, right? In other words, if I divide 10 by 2, it's now square root of 5 times square root of 5 over root 2. Well, that immediately becomes 5 over root 2, which that answer is not on there because it needs to be rationalized. Are you familiar with that expression, rationalizing the denominator?
Uh-huh.
And then we get same thing we came up with doing it the other way. Maybe a little quicker. If I divide 10 by 2 and make this root 5, it does make the whole problem a little quicker. I'm not faced with having to simplify root 50. Although I do have to know about rationalizing denominators by doing it this second way. Okay, well, my wish to get more data sufficiencies isn't holding up, but we'll run into some.
For all integers a and b where b is not equal to 0, subtracting b from a must result in a positive integer if.
And we know only one of these can be correct.
Mm-hmm. Well, it can't be a.
Right.
Because that answer can both be positive and negative.
Right.
And so could b.
Yeah, B doesn't make much sense.
A divided by b is a positive integer. Well, again, you don't know if it's a minus or both. A could be.
Well, if A divided by B is a positive integer, it definitely means A is greater than B.
Mm-hmm.
And therefore subtracting B from A would result in a positive integer.
Oh, yeah, because when I saw it, I thought it was like b minus a, and I was like, that doesn't make sense, but of course it says subtracting from a.
Right. The key is positive integer. Ooh, hold on. No, C is not the answer. Notice that if A were equal to B, and you divided A by B, you would get a positive 1, which is a positive integer. But you would not get a positive integer by subtracting B from A. So C is not enough. Let's look at E. In other words, this isn't a...
Oh, because that would be 0, you mean?
Right.
If a and b were equal,
Right.
then it would have to be 0.
Then, right. And yet you would still get a positive integer by dividing A by B.
Yeah, well, the d, it's not possible for d either because...
No, this isn't negative times negative or negative divided by negative. This is going to be something like E. So if B minus A is negative,
and a minus b is positive.
has to be positive. the principle here is A minus B is always equal to negative of B minus A.
Okay, yeah.
Okay? And that can come in handy for some other reasons also. If I tell you, if I ask you, what is this equal to? It's negative 1. Because I can write it in the following way. X minus 3 over a negative 3 minus x. Excuse me. 3 minus x, if I multiply the top and bottom by minus 1, I get the negative sign in the denominator, negative sign in the numerator, but I know that 3 minus x is equal to the same thing as negative x minus 3. So now if I switch that to that, make that, now I multiply, cross those off, and I'm left with a negative sign. And this is something that a lot of people don't often see if they're trying to cancel. In other words, you know that if I end up with something like this divided by an x plus 3 times a y, I can cancel that with that. But a lot of people don't know that they can cancel an a minus b with a b minus a as long as they turn it into a negative 1.
Uh-huh.
All right. $14.
In the figure above, m, there's no m on that figure.
That means the measurement of angle ACB.
Is 90 degrees.
So this is a right angle.
What is the length of D to B? Well, if I was to guess, I would say that that is a 90, 30, 60.
Well, let's hold on. Let's put
Or
what we
it's,
know on there. What is this end right here? What's that side?
20.
This looks like a 3, 4, 5 triangle, right?
Yeah, well, it's 3 times.
That would have to be 12. In other words, if I divide everything by 3,
Probably 4.
oh, hold on a second. No,
That's not right.
No, it isn't right. It's not a 3, 4, 5.
Oh, it's 5. It's supposed to be.
Oh, yeah. If I divide... No, this is not a 3, 4, 5 triangle.
Well, it can be because it says figure not drawn to scale.
Well, that's true, but it's real tempting to try to make this into a 3, 4, 5 triangle because these are multiples of 4 and 5.
It would have to be 25. That was the answer. But then that would
Well,
make the hypotenuse not long enough.
If we look at our answers, they've got some strange answers down here. First of all, do we know CD? You know what kind of triangle that is? 15, what? 17. That's 8. That's the third that's the third largest perfect Pythagorean triangle. You have a 3, 4, 5.
Yeah, and
You
then
have a 5, 12, 13, and then you have 8, 15, 17.
I can never remember that one. I always remember the 9, 40, and 41.
Well, you can always use the Pythagorean theorem to come up with this. Okay? So I guess my point is that if I know this is 8 and I look at my answers, it's quite reasonable. All 4 out of the 5 answers well, B can't be the right answer. If CD is 8, then CB is certainly not 8. So all of my answers have a radical sign in them, which now tells me that there's no way CB is an integer. So that's not a 3, 4, 5 triangle. So I have to figure it out. So what is CB equal to? And once we get CB, we'll subtract 8 from it, and we'll have our answer. So we know our answer is either C or A.
I
we're gonna have
still say that you could like estimate, sort of.
Well, let's figure it out. It's worth knowing how to solve Pythagorean triangles, always. You definitely want to be able to do that. So if we're solving for one side, CB is going to be equal to what? When you're solving Pythagorean triangles, it's always the square root of something, no matter whether you're solving for the hypotenuse or one side.
Well, I'm just thinking you have A, which is 15.
I have one side, which is 15, and I have the hypotenuse, which is 20. So what's the other side?
Well, it would be
It's the hypotenuse squared minus the other side squared. Okay, so now we can approximate that. That's 400 minus 225, so that's 175.
Yeah.
Now can we tell the answer without going any further?
No.
Well, actually, simplify 175, and you're going to see one of those factors is 25. That's 25 times 7. 25 is a perfect square, so it's 5 root 7 is what 170.
Yeah, well, I was just gonna say, like when you said, can you find the answer when you just have square root 120, like square root 175, and that's what I answered. No, you cannot.
Well, no, I know, but what I saw when I saw square root of 175, I saw 7, square root of 7 times square root of 25, and there's the square root of 7 right there. I know we have to subtract 8 from it, so C has to be correct, not A. In other words, there's no way to simplify 175 and end up with a root 21. But you can end up with a root 7, because 7 is a factor of 175. So if the whole thing is 5 root 7, then this must be 5 root 7 minus 8 dB. All right. Let's see, 15.
Well, you have two.
Here's my two equations.
Can't you subtract them?
Well,
or multiply them or something. So
I want to solve for x. So I want to eliminate y. In other words, if I'm going to use elimination to solve these for x, which I would like to use, elimination I think is the easiest way to solve two equations and two unknowns. Now it looks like there's four unknowns here, but we're actually going to solve for x in terms of a and b. All of our answers have a and b in them. So if I can eliminate y, I'll solve for x in terms of a and b. So what do I have to do to eliminate y? I'm not sure if you're necessarily familiar with this technique of solving by elimination.
Well, can't you just multiply so that y's become equal?
Yes, that's exactly what we need to do. So let's
multiply
yeah, or add it. It's easier to add. So I'm going to multiply the top by 3, and I'm going to multiply the bottom by 2.
Mm-hmm.
Every part, right side and left side.
So that
Okay.
equals
Now we got
9x
9x plus 6y equals 15a plus 3b. On the bottom, we have 8x minus 6y. Now we're going to be able to add them, and the y's will disappear. Okay, so now I'm going to add these two equations, which you can always do. What do I have? I have 17x equals 17a plus 17b. So what is x equal to?
a plus b.
Uh-huh. Okay. Go to the next page. My goodness, look at all these for a data sufficiency. They don't have a lot of data sufficiencies in here. All right, let's do 16, crooked 16.
Do you have any other tests that have some of them in there?
Well, we've got plenty. We could just go straight to data sufficiencies and skip all the ones that aren't. That's fine with me. I've got 5 total tests. We've only looked at 1.5 of them.
Maybe just for like, you know, for the next 6 minutes, like that's just
Okay,
easier.
let's do that. Yeah, because we've done a string of about 10 problems here where there are no data sufficiencies. So the only thing about jumping around is we may need more problems to do. We'll want to remember where we left off.
Mm-hmm.
All right, let's look at 21.
What is Michael's monthly salary? Okay, well you can take number 2
Okay.
and say no. Because you have no idea what to calculate.
I agree. And much easier to analyze 2 than 1. And the advantage of knowing that 2 is a no is that if you were to run out of time right now, and you didn't have enough time to finish the problem, you could make a very educated guess just knowing that 2 is no.
Mm-hmm.
Whereas if you'd have spent that 10 seconds trying to analyze number 1 and you ran out of time, now you're not nearly as good a position to make a guess.
Mm-hmm. If Michael's monthly salary were cut by 25% while Sam's monthly salary was raised by 25%, they would earn the same salary. Well, I'm still going to say no.
No for 1.
Yeah.
Okay. Let me think about that for a moment.
The reason I want to say that is because you could pick numbers, but that wouldn't really tell you what his salary is.
Yeah, let's say, well, are there more than 2 sets of numbers where that works? In other words, if Sam earned $1,000 a month and you cut his salary by 25%, he would go down to $750, and he would have to earn about $600 a month, where if you increased it by 25%, he would go up to $750. That tells you Sam earned $1,000, but it could be $10,000 and $6,000, and the same thing would happen.
Or 100,000 and
Right. So 1 alone doesn't work, but now that's helpful to know. If Michael's salary is $1,000, then this is the only solution that works.
no, because it says Michael's monthly salary is $1,000 more.
Excuse me. You're right. Is more than okay. So I know I have to have this ratio. I think it still works because this difference is 400, and they're saying it has to be 1,000. So I need to multiply this by 2.5 and this by 2.5. So Michael's salary must be $2,500 and his salary must be $1,500. And that's the only two sets of numbers where 75% of this number is equal to 125% of this number.
Yeah, but the answer would still be C because you need both of them to figure
Yes,
it out.
but you can do it with both.
Yeah.
Which I wasn't clear on until that.
But why, I mean, I'm just saying, like, how, so you just know that you have to multiply by 2.5.
Well, the information they give us is their difference is 1,000. And in the numbers that I picked, I got a difference of 400. So I knew that this could be 10,000 and 6,000, but that's a difference of 4,000. So there has to be two perfect numbers that are separated by 1,000 that still have this relationship. And I knew that if I multiplied this by 2.5 and this by 2.5, they would be separated by 1,000.
Mm-hmm.
It's a bit of a stretch, but you try to solve these data sufficiencies however you can. They can be brutal.
Yeah.
That one's a
Also,
pretty...
I mean, you also calculate it pretty fast, you know, what numbers. I mean, obviously, I can calculate 25% of 100, you know, but I would probably have a hard time figuring out the 600.
Well, I agree, and part of the GMAT is being able to do that arithmetic as fast as you can. That's why I really encourage people to, if I were you and I wanted to do the single most important thing to raise my grade on the GMAT, I would even say more important than paying me $32 for an hour tutoring session is for 10 minutes every night for 2 weeks before your test, drill yourself on multiplication, addition, division, subtraction.
Well, yeah, I've done that.
Okay, and there's lots of ways to do that. You can get digital flashcards. You can go to internet sites that'll just flash you problems and you have to give the answer. And just drilling will make you faster and more accurate. I think that's the only way to do it. There's no way to really improve skills at arithmetic without drilling, I don't think.
Yeah, I mean, I think it was just like thinking about it, I was like, but what 25% of what number is 750, you know?
Right, right. No, I agree. That was a hard problem, and it was helpful to be able to do the math and find ballpark numbers.
25% of 600 is 150, and then you know, increase
right,
it.
you add that to 600 to get 750. Yeah. But I was lucky, really, in what I picked. In other words, I picked 1,000 and realized that 600 would be the perfect combination, where 75% of that's equal to 125% of that.
Mm-hmm.
All right, let's look at 24. Let's do one more data sufficiency.
Yep.
And
Mona has $2.05 in quarters and dimes. How many quarters does she have? Well, you can easily say number 1 doesn't count.
we can't determine it from number 1?
No.
Well, I'm not so sure we can easily rule it out.
Well, I would say, okay, number 2, you can definitely rule that one out.
Well, the key here is the 5 cents. You can't have $2 in quarters, right? Because you wouldn't be able, you don't have a nickel. In other words, you have to have a combination of quarters and dimes, so there's no way you can have 8 quarters. Could you have 7 quarters? That would be $1.75, and then so you could have 7 quarters and 3 dimes. That works.
You would also have 5 quarters.
And 8 dimes.
But then
And that's the only two combinations, and only one of those.
Yeah.
In other words, number one actually does pin it down. If she has more quarters than dimes, she has to have precisely 7 quarters and 3 dimes.
Well, then 2 works too.
She has a total of 10 coins. You're right. 2 does work. I think. Let's see. Could you have... No, yeah. 2. Any other combination is not going to be 10 coins. So...
Wait a second. If she has 3 quarters...
Yeah, no, you're right. 2 works also.
But if she had 3 quarters...
Okay, that's 75 cents. And that would mean she would have 13 dimes. In other words, as you reduce the quarters, this has to go up by more. Notice that when we reduced the quarters by 2, we went up by 5 dimes. So any other combination is going to be more than 10 coins.
So actually both of them work.
Both of them work individually.
Okay.
That's a clever problem there. That's more typical of how tough their data sufficiencies can be. They look like there's an obvious no, but it turns out that if you spell out all of the combinations where you can make $2.05 with quarters and dimes, there aren't that many. So, all right. So we got through 24. I'll make a note of that, and then we can pick up tomorrow. Let's see. I'm going to see you tomorrow at 5 and on Saturday at 4, right?
Yep.
Okay. Talk to you tomorrow.
Talk to you tomorrow.
Bye-bye.